Welcome to lesson 7.14. Today we're looking at two different ideas. First idea are problems, not necessarily word problems, just problems about part of a whole. And then we'll also look into the basics of probability today also. So starting with that idea of parts of a whole. When it comes to parts of a whole, it's this picture. You have a part plus a part equals a whole, right? Really, we're getting into the picture of fractions. So A plus B equals W. And this is a concept that it's going to sound new, it's going to sound different, but really it just hasn't been defined that way before. You've been working with unknowns and working with fractions and finding parts of a whole for a very, very long time. But we're kind of getting to a point where we need to think a little bit more theoretical about math because we're going to start dealing a lot more with variables as you advance in math. It's not necessarily going to be solve for this number, but it's going to be show me how to get to this point. And that's kind of what happens with higher levels of math. Let's go ahead and look at this picture then. What does a part plus a whole really mean? And it gets into a problem like this. It says 1/3 of the students attended the game. What fraction of the students did not attend the game? Right? And so pictures become very helpful on this. And so I drew a picture, right? It shows a third colored in and 2 not colored in, which means that we have this idea. Now, if we're going to follow our pattern, A plus B equals W, right? What does that mean? It means I have a part. I was told a third didn't attend. I don't know how many did not attend, right? I wasn't told any numbers, right? I don't even have exact numbers of anything, but together these two numbers equal 3/3, right? It equals the entire student body, right? So even though we don't have exact numbers of what that 1/3 is or what the unknown is, we have these fractional ideas of how we can express this idea. And so how do we solve for this? Really, you're probably just staring this as like, okay, I can do this in my head. And it's like, good, great. I'm glad that's easy to pick out, and hopefully this concept will be easy. But we do want to remember this concept because eventually we're going to get into much, much harder problems than what this is saying, right? Because your brain is ready for it, right? Your mind is ready to be challenged in that way. But when we solve for this, right now I'm going to just count, right, 2/3. And if I did some rearranging, I would find out that B equals 2/3, right? To get B alone, I'm going to have to do that. Let me just show that just in case, right? I would have to take that 3/3 minus the 1/3 to get B and solve for that. All right? The picture definitely does help. However, pictures, as wonderful as they are, sometimes they don't give us all the information that we need. And so here is your challenge if you work with sample 1. It says Melisenda's science beaker is 61% full. What percent of Melisenda's beaker is empty? You only see one number, but what does full, as in completely full, what percentage does that really mean? That's my hint as you work with that sample. All right, we're going to move on to probability then as you work through that sample. Hopefully you've paused the video and solved that problem. But probability. Probability is one of those concepts, we see that word and it's just like, oh man, this thing is hard. And really it's just saying, let's compare the likelihood of something happening with fractions. Well, that makes it sound easy, almost too easy. But that's really what it is, right? So first of all, we have this pattern we're always going to follow, right? To find probability, it's going to be the number of favorable outcomes, or what you're looking for, over the total number of possible outcomes. And we're going to play around with that concept in just a minute. Another thing that often comes along with probability is determining that likelihood. And so we create a very, very simple chart that we can use to help us understand the likelihood of an event, right? If I use this pattern and I get a fraction that is equal to 0, which means the 0 is on top, that's the only way you're going to get to 0, that means the probability is impossible. It is impossible for that event to happen, right? The it would be if I get a fraction, let's say it's 3 out of 3 possibilities, right? It's guaranteed. It's almost certain. It is certain that it's going to happen because there's that 1 when it comes to it. Now if I get a fraction that's a half, it's equally likely to happen as to not happen, right? Right in the middle. And then of course if I get a fraction that is less than 1/2, then it's unlikely that that's going to happen. If I have a fraction that comes out more than 1/2, it's likely to happen, right? So if I end up with a fraction like 3/4, right? That says, okay, that is more than a half. This event is very likely to happen. Compared to if I get a fraction like 1/4, this event is unlikely to happen. It's not going to happen as often as one of these other events. So we have these different ideas. Here are the main concepts. Let's work through some problems and apply some of these different ideas. Often when it comes to probability, we look at number cubes, we look at spinners, we look at different ideas like that. And so let's work with our number cube. It says a number cube has 1 through 6 dots on the faces. You don't believe me? There they all are, right? If the number cube is rolled once, what is the probability of each of these outcomes, right? So we're going to use this pattern, right? This pattern right here to help us solve this idea. Okay, we've got 4 different problems. Say, rolling a 4. So what do we want? What is our favorable outcome? We want a 4. Well, how many 4s are on a number cube? Well, there's only one. There's 1 4. How many different sides are on this number cube? Right, there are 1 through 6. So it's 1 out of 6. That's our probability. It's a 1 out of 6 probability. Okay. Second one, rolling a number greater than 4. Okay. So if there are 6 numbers, it has to be greater than 4. Right. Greater than 4. So 2 numbers are greater than 4, 5 and 6. So that means we have 2 favorable outcomes out of the 6 possible outcomes. But because probability is written as a fraction, we also must treat it like a fraction, and so we must reduce, right? 2 6 is going to reduce, and I'm going to throw it up here in a different color. It's going to be 1/3, right? Because I divided by 2, right, on the top and the bottom, okay? Letter C then, rolling a number greater than 6. Rolling a number greater than 6. So what numbers are greater than 6? That would be 7, 8, 9, 10. How many of those numbers are on a 6-sided cube? Numbered 1 through 6? None of them are. Exactly. So our answer to C is going to be 0 out of 6, right? So that is impossible. It is impossible to roll a number greater than 6 with only 1 cube. And then finally we have our last concept, rolling a number less than 7. Right, less than 7. So numbers less than 7 would be 1 through 6. So that would be a total of 6 favorable outcomes out of the 6 possible outcomes. And so in the end, we get these probabilities. Going back to this idea, now we can compare them to our graph. What is the likelihood of these things happening, right? Looking at this box right here. And so how does this apply? We would say, okay, a 1/6. Is this fraction equal to 0, equal to 1? Is it equal to half, or is it less than half or more than half? And this, of course, is less than half. So rolling a 4 is unlikely. It can happen, but it's unlikely. Rolling a number greater than 4, right? We came away with a 1/3. 1/3 is still smaller than a half. And so we would say this event is also unlikely. It's not as unlikely as this one, right? Because it's closer, right? If we were to put these on our line, right? We got our 1/6 would be about here, and our 1/3 is going to be about here. And so, right, it's a little bit more likely, but overall, it's unlikely. Finally, we have rolling a number greater than 6, right? We came away with this idea, 0 out of 6, which is 0, so that's impossible. We already mentioned that already. And then rolling a number less than 7, which gives us our 6 out of 6, which means that we're going to have that. It's going to be certain. We know we're going to get one of those numbers because that's what's on our number cube. That was fast. So if you need to go back over that section and think about it, go ahead. Here's a sample problem. It's working with a spinner, and you can see our spinner is divided a little bit differently, looks a little bit different than your typical equal groups spinner, but you're looking for what is the probability of the spinner stopping on 3. So you got to think about the different sections, and a little bit harder one to challenge you as you go through this. If you have questions on this, write them down now, right? On any of this stuff, write it down now, and then be ready to ask those questions in class. If you don't have any questions, all right, it means you're probably set to go for next class. That is lesson 7.14 or 7.14.